come as linear. Find best that maximizes or minimizes the programming. Actually, is one tool that is by business. Also, you can, for example, a housewife like to buy your ingredients, like to buy those ones which test, so that at the end, cut down your. Same thing applies to come to business. They want to produce. They also want to find a combination that minimizes their cost at the end, maximizes their. And what is linear programming? Linear programming is a mathematical technique used to allocate limited resources optimally to achieve best outcome. To achieve best outcome. All right, there are some assumptions we need to make the linear programming problem. One is linearity. For the linearity assumption, it assumes that there's a linear relationship between variables. As one increases, the other also as one decreases, other decreases. Then with the additivity that the power of above, the combination, the individual summation of resources above. Then the non-negativity that your output can be negative. Have you ever heard of a company saying that use negative output? No. So the non-negativity or output by a company or a firm or a business the industry are positive. Then one thing you need to know the efficient or the profit, the cost, resources are known and they are also constant. Also, it's important for you to one is the objective function. What is the function? The objective functions goal. The underlying word is goal. Goal of the problem. And the goal of the problem can be either to maximize profit or your revenue and to minimize your cost. So we can formulate a linear programming problem, determine the best combination of the decision variable that maximizes a company's profit or minimizes it. And also is given by the form where the A and B are the coefficients, where A and B now. What are decision variables? Decision variables are variables that represent quantity and to optimize the objective. Also, they are also subject to constraints. They are controllable by the organizer. So this previous in your previous equation like this, and say that the x and the y are decision variables, represent the quantities that the company combine in order to achieve the already established objective function. And the constraint, companies would like to have certain, they are limited by their scarce resource. They are unable to achieve their set goal target. So what limits them? That's their resources. The resources are the available quantity that restrict or bound values of the decision variables, a linear programming problem. They are represented as inequalities in the model. They are represented as inequalities. Notwithstanding too, you can also have equalities in the model too. So when you see this is how you write the constraint, normally see something like this. X plus y less than or equal to or half x plus y greater than or equal. You can also have equal. So if we have these things, they are constraints. Then what is a slack variable? So a slack variable represents the unused portion resource, the unused. And for slack variable, they are normally used as they are using the equal to introduce in the less than or equal to, and also the leftover after satisfying the requirement, after satisfying the requirement. And one thing you need to know about the slack variable is the constraint has the less than or equal to. Then to make the or to change the inequality to what equality, you have to add something positive to the left hand side. Connect it to what equality. What we add, the positive thing we add left hand side of the equation, the inequality, to convert it to a standard form. That's the equality, the slack variable. Slack variable. For example, let me have 2x less than or equal. This is an inequality function. An inequality function. Then we are saying that for the constraint out leftover, meaning that whatever we have at the left hand side of the inequality is less than or equal to what? 10. Now, how do we make it equal to? How do you make it equal? That's the left hand side equal to the. We to add a figure to the what? To or something to the left hand side of the equality. And also by adding, we convert it to equality. Now the left hand side has become what? Equal to the right hand side, making it equal. So if I'm to add a class as s, then I can say that the left hand side equal to the what? The right hand side by adding this variable, that is the slack. And also you need to know that if the slack is 0, then the resources available have been fully used. And that if they are greater than 0, then we have what? Extra available, and it gives us what? A surplus. That's surplus. What's a surplus variable? Also, a surplus variable, they represent the excess amount produced. Surplus mean that the excess amount produced beyond the minimum requirement. The excess amount beyond the requirement. But let me give you an example about the surplus variable. If you're a company and you are required to produce, let's say you're contracted to produce 100, let's say 120, maybe more than you are required to produce. So the 20 on it, that was. Also, another typical example under the slack variable is when, let's say, you have a budget, or you budgeted to spend, let's say, 100 Ghana cedis of your by the close of the week, and you end up spending 8 Ghana cedis, meaning that there's an amount left, which is 20 Ghana cedis. 20 Ghana cedis, the unused portion. of your what of your money or your resources. That's the 20%, and that becomes the slack variable. Also, the surplus variable, if the constraint has a greater than, if using a greater than or equal to what constraint, greater than or equal to. For example, you have x as y is greater than or equal to 6, meaning that the left hand side greater than the right side. Now convert equality to what equality. That's when we have to subtract something positive from the left hand side with the left hand side of the equation, the right hand side of the equation. What this one means is that this portion greater than equal to this. Now, how do we make the left hand side equal to the right hand side? You have to subtract something to reduce it. Assuming we have 70 here, meaning the 70 is greater than or equal to 6. What do we have to do? Subtract something, 70, and make it equal. What you subtract this portion is the surplus variable. Surplus variable. All right. What's the binding resource? Something is binding, meaning that the resources have been fully used. This is that we have no slack left or excess surplus. And also, one thing you need to know about the binding constraint or the binding resource. Those are binding if you have the left hand side being equal to the right hand side of the equation. The left hand side is equal to the right hand side of the. Assuming you given a linear programming problem, and you are making an assumption that you have one of the constraints by less than or equal to, then you have x y is less than or equal to the rest. They are there, so I'll just pick two. Then you solve for them and you determine your optimal solution. The x equal to 30, y equal to 40. Then given these two constraints, which one is binding? Which one is binding? What you have to do is put this x value and y value into doing that. For the first constraint, x is 30, y is 40, 70. So 70 is less than or equal. Because the resources have not been fully used, this one non-binding. Binding. Now let's check the second. Is 2 as 40. And here is 60 in as 100. Meaning that the second constraint is binding. There's no slack or excess surplus. The non-binding resources, they are not fully used at all. And as a result, we have some surplus or some slack in them. Indicated in our example here. So next constraint, 70 is less than, so we have lack of what's the or the optimal solution programming problem. And also for redundant resources, because it doesn't affect the whole reason. Non-binding has a slack and does not necessarily alter anything in a linear programming problem. All right, let me give you a typical example. Assuming you want to cook, and just have 5 ingredients available for you. Just have 5 ingredients available for you. Out of these 5 ingredients available, you only need 3 of them. You only need 3 to get ready meal or your food ready. Then, how many ingredients are you left? You are left with 2. These 2, though they are available, but they are not due for being redundant, even they are available. They don't contribute to the preparation or the taste of them. Redundant. Redundant. But one last, that's shadow price. What's shadow price? Shadow price is basically the rate of the objective function to minus cost. For a 1 unit, or the right hand side of the binding, shadow price only applies to binding that in the constraint is not binding, doesn't apply. That the constraint needs to binding for the shadow price. Basically, you are looking at how the objective to like the example we saw about 2x plus I. We are to increase this one by 1 unit or increase it by 1 unit. What effect will it have on our objective function? That is one of the price or the dual value. So, we also have something like the feasible region. Feasible region. And bounded or not bounded. So if feasible region is bounded, that it's enclosed by all the what? Bounded. Bounded. It's bounded, meaning that it is enclosed by all the what? Or the bounded, and there's an open as open to at least one direction of the. Let me draw. Assuming you have some program. Therefore, bounded physical region. Bounded physical area. Bounded, they are what? Enclosed. They are enclosed by the then unbounded at least open at one side. Constraint.